Okay, welcome back. Now we're going to do a theorem, go over a theorem here. This theorem, I call it Theorem 1, says that continuity is dealing with continuity of polynomials and rational functions. So the theorem simply states this, that polynomials and rational functions are continuous at every point in their domain. That's it. Okay. Now, I'm not going to show the proof because we already showed in previous video, we showed that a polynomial, if we're given polynomials, p of x and g of x, we showed previously that those polynomials are equal to p of a and q of a at every point in their domain. So remember that polynomials are defined everywhere, all real numbers. Okay, that was one of the things we showed. Also, we showed that p of x, the limit of p of x, right? So we did discuss limits, right? We showed the limits of p of x and the limit of g of x equals p of a and g of a, respectively. We also showed that if we take the limit of the ratio of p of x over g of x, that would equal, using the limit laws, remember, that would equal p of a over g of a, based on what I was just saying in the last video about just substituting in for x, substituting in a for x, okay? So, in other words, going back to what I was saying, so if you have a rational function, p of x over g of x, and you take the limit as the x approaches a, we showed previously in previous videos that will give us p of a over g of a, provided that g of a is not equal to 0. Again, which is the same thing as rational functions as far as their domain. So it's basically proven based on what we've already done. So I'm not going to go over that proof. Well, I pretty much stated the proof in words. So now an example, so remember, all you have to do is remember what's the domain of polynomials. Polynomials are defined everywhere, so they are, in other words, continuous everywhere, at every point. What about rational functions? Remember, rational functions are defined everywhere except whenever there's a 0 in the denominator, right? So those are the restricted values. Again, going back to algebra and pre-calculus. Okay, so where is this thing continuous? Well, what's the domain? Well, we know the domain of this function is the set of all x such that x is not equal to 5. That's the only restricted value, because if x is 5, you get 0 in the denominator. So the domain is, hey, everywhere except x equal to 5. So guess what? Where is this thing continuous? This thing is continuous everywhere, or at every point except x equal to 5. And that's it. It's that easy. Have a great day.